Hello! A new block for Steve's Factory Manager is here. It's super late for me, but I want to, well, get this out before I go to bed, so I will keep this as short as possible. So the new block is the Block Detector, which you can craft using the cable, the inventory cable, and you put that together with 3 pieces of quartz. So just any shape for that recipe, the inventory cable with 3 pieces of quartz, and you get the Block Detector, which is kinda a block update detector. You might have seen them from other modes, you might have built vanilla ones as well. It's kinda like one of those, but like more advanced. So let's see. Right, so first of all I want to set up a small test system here, like that. Okay, so here's the Block Detector, and here we just have a redstone emitter. Right. Okay, so no new commands here. We have the same amount here, but in the trigger we have a new set of connections. So we have the on-interval one like before, the redstone controller one like before, but we also have the block update detector here, and as we can see, a few menus. Nothing special with this menu. We just select the block detectors that we want to use. If we select multiple ones, we can define how that selection should work, if all should be required, you know. Here, nothing new here either. Oh, well, here's the interval, nothing new there either. But here, sides. What sides should we work with? I'm going to select only the west side, so we don't have to interact with anything else around it. But this is important in some cases, but not everything. Right? And then we have this thing here, which is quite an advanced menu, so more to that later. What I want to do is, when I get this to trigger, I want this emitter here, this redstone emitter, to pulse for half a second, just to indicate that we triggered something. We have 5 different pins here, more to all of them later, but for now I'm going to use the middle one. So the middle one is basically a block update detector pin. So now if I place a block or remove a block, that happens, actually even on the other sides as well. So a block update has nothing to do with the side, and therefore the sides here won't really affect it. So we can see that these sides might not do what you expect them to do, but they are important when you go into more advanced things. But as you can see, as soon as it gets a block update, we don't care about where it's going to do that trigger. Right. Okay, this is a block update detector. If that's the only thing you want, done. Is that the only thing I'll supply you with? No, of course not. Right, so let's get into the update block here. So first of all, press use ID. Now we can define, for instance, 1. Okay, so put the grass down, nothing happens. What has ID 1? Well, that's a stone. Put down the stone, and we get that pulse. Put down the grass like we saw, nothing there. And as you can see, now when I remove it, the blocks, nothing happens, because when we remove it, we get air, which is ID 0, and nothing happens. That allows us to go in here and, for instance, specify 0, and then invert it. That means that everything that's not air is going to trigger it. So that triggers it, and that's also triggering it, but as you can see, when we remove it, it's not getting triggered. And of course, that means that if we do it like that, when we remove a block, it's going to get triggered. But that's not what I want. So I can just press here again. Now it won't care about the ID of the block. Let's take a look on the metadata here instead. Right, so what is it? Well, let's ignore this part for now, and let's just take a look on here, this part. So we have the lower range and the higher range of the allowed metadata. At the moment it goes from 0 to 15, which is the full range, which means that we don't really care about the metadata. Right, so let's start a farm, shall we? Right, so now when I place this seed here, as you saw, that pulse, because, well, I placed a block there, we got a block update. But this has metadata 0 because it hasn't grown anything. So now when I trigger something here, it's going to pulse there. But if I go into here and say, well, I don't like it to be 0. 0 is not fine for me. Now if I place a block here, nothing is going to happen, because this hasn't got ID, well, not ID, but metadata 1 to 15. Okay. Let's do it like that. When you grow a plant here, it's not actually going to trigger a block update. So unfortunately, what you will have to do is place a block here. But as you can see, now it triggered, and that was because this was higher, like so. As you can see, it also triggered when I removed it, and the reason is I've specified the side as being on the west side. So it's only going to care about what I have here, even though the block update goes here. And that's just a restriction for how block updates work. You don't really know where they come from. So if I place here, I'm still going to take it like so. So now I can actually control that by placing or removing a block here and then having a specific block here. But that seems a bit silly, right? You like just place and remove blocks just to get that. So we'll see a smarter way very soon. But before we do that, I want to continue with this menu here. Right. So of course we can invert it as well. That's very simple what that does. It says that 1 to 15 is invalid and 0 is the only valid one. So maybe if you want like 3 to 12 to be invalid, and then you can say it like that. So then we get 0 to 2 as valid and 13 up to 15 as valid as well. So that's nothing special there. Right, but some things act a bit different. So let's take the anvil for instance. So how do you think the metadata works for this one? Well, when we place it, depending on which direction it's placed here, one of the bits of the metadata is going to define which direction it is, and then somewhere else it's storing how damaged it is. So as you saw when I searched for anvil, we have 3 different states here. So we have these anvil, the slightly damaged anvil, and very damaged anvil, which means that will have to be stored as well. So what we can do, you need to know how it's stored, but the Minecraft wiki is pretty nice for that, so you can get the information from there. So like I said, in 1 bit it's stored which rotation it is in. So then I might just want to check the first bit. So now I'm checking just the first bit, the lowest, so this is the least significant bit. If you don't know about what bits are, then just skip this part here. So you need to know a bit more how the metadata works to utilize this part here. So now I'm looking for a 1 here, oops, like so, and I don't really know which direction is which here. So yeah, so one of the directions there, then we can detect that. So you're looking for a 1 on that bit there. But then we can take the damage, like how damaged an anvil is. That's on these 2. So then we might want to look at there. And as you can see now, the maximum here I can go to, I can't type anything over 3. So I just get 0 to 3 here, which is basically the different numbers I can get from 2 bits. So now I can say, alright, I just want to detect a very damaged anvil. That is if the 2 final bits are, well, 2. So now 2 to 2. Or if I want to detect something that is damaged, but it doesn't have to be super damaged, then I can look for 1 and 2 here. So I'm just telling it, look for these 2. Or maybe if we want to work with crops, then we want the lowest 3, because that's how far the crop has grown. Or maybe we want with saplings, then the highest one here is if it's a growing state, whereas these 3 are for the type. So maybe you want to detect multiple things. So as you can see now, I've created multiple settings. What this means is if you have multiple ones, all of them have to be true. So maybe you want to check, alright, I want this to be 1. So I want the anvil to be in the correct state, like so. But I also want it to be not damaged at all. So therefore I'm looking at these 2 like so. And I don't want this 3rd one, so I just deselect them all. So if you deselect them all, they disappear, and then it's not going to count them. So now I need both this bit here to be on, and these 2 together to be 0. So even though these 2 would count as like 4 and 8 when you count in binary, it's still going to merge them as if this would be a value that went from 0 to 3. Even if you did it like this, it will merge them into 1 value. So now this is the least significant, and that's the next bit, and that's the next bit. So we can go up to 7. So it's going to put them together like so. But yeah, so in this scenario, I would like it to be like that, and I will left that out there. And then I could specify the ID here of the anvil. I don't know that off the top of my head. 145. So I would just write 145 there, and that would allow it to only detect the anvil. But like we saw, when we had a growing crop, it couldn't update, because a block update detector only detects the updates itself, and those are like when we place a block, remove a block, or when we I don't know, flip a lever when we stand on a pressure plate, I don't know, when a redstone signal arrives and so on. So it's not, well, super reliable if you want to check if a crop has been grown and so on. And like I said, it's very useless for us to just place a block here to check that. So I've set up a little system here where we can take a closer look on the different pins here. Okay, so I have the on high pulse, while high signal, on block update, while low signal, and on low pulse here, all connected to these different 5 emitters. This time they won't pulse, they will flip back and forth, so we can take a closer look on where when it happens. Here I also have the timer set to 1 second, and I'll select the block detector there, and let's select it just on the west side so we don't have to bother about multiple sides, and there we go. Okay, so at the moment I don't care about anything here. As we can see, one of these are actually blinking, which means that, well, every second we tell it to update. And that's the while high signal. Why is that updating? Well, on the west side, we have a true condition in some sense. Because what are we looking for? Well, we're looking for anything, and there's anything there. Well, there's air there, but that's anything in our opinion, and therefore it's fine. So that one is just going to pulse back and forth. If I place a block here, we can see this one update. The reason why that updates is because, well, we just got a block update. Well, yeah, we got a block update, and therefore it updated exactly like we worked with that. Remember, the middle one is the one you want to use if you want a block update detector. Right. Okay, so that's what just pulsing on, and all of these others are off here. And they will actually be kept off. We can't make them turn on here, just because it's always going to be true. Right, so let's use an ID instead and specify that we want to invert this. So now we're looking for anything but air. And as we can see, now this one is pulsing back and forth. This got stuck in the up state just because that's what the state it happened to be when we did the switch. Right, so now this is pulsing, and that's the while low signal. So what that means is that, well, what's the condition here? Well, we're looking for anything but air. Do we match that? No, we do have air here, and therefore the high signal is not going to be on, but the low signal is, and therefore that's going to blink like that. If I place a block here, we can see multiple things happen. First of all, this starts, and that stopped. This switch state, because, well, we got a block update, but also this switch state, which is the on high pulse. The on high pulse is going to give us a trigger when this state here changes. So we went from, well, when it changes to the on state. So we had something that were air, and then we went to something which weren't air, which is exactly what we're looking for, and therefore that got triggered. So we didn't have air, and then we went, well, we did have air, and then we went to what our conditions suggested, and therefore it got triggered like that. The trigger itself can, well, those two, the two on the sides here, they can get triggered when a block update happens, but also when the timer happens. So if when the timer happens, something has changed that brings it towards, well, either on or off, depending on the condition, it's actually going to trigger. So let's recall what the problem we had over here. Well, when the I got rid of the hoe actually. When the crops grew, we couldn't really detect that because we didn't get a block update. But each time this pulses, it will actually check if something has changed. So it doesn't really require a block update. If you want to use it as a block update detector, then you can of course still do that. Just use the middle one. So what we can now see if we do something a bit more advanced here. Okay, so I'm going to place that there. And now I'm going to change the condition here to be 59, which is crop. And I'm not going to use that, I'm just going to use these guys, and then set it to 7. So a crop is fully grown when these 3 bits together form the number 7. Right. Okay, so now this is blinking again. Why is that happening? Well, that's simply because we haven't met the condition, and therefore it's going to pulse on and off each time this interval reaches 0. So that's what's happening there. And then I continue to use bone meal here, and boom. There we go. So as you can see, now this is pulsing, and that got turned on. But as you can see, this didn't turn on because we didn't really get a block update event, and that's sort of the downside with crops and so on. But this triggered anyways, and as you might also have seen, it triggered at the same time as this one triggered, and that's because this is also controlled through the timer. But these things on the side, they are also controlled at the same time as this one. So if you have a timer set to like 100 seconds and you just want to detect differences, well, once every 100 seconds, even if that's the case and you get a block update, these two on the side will still analyze the block at the given sides and see if something has changed. So the two on the side uses both the timer and the block update itself, and then checks if something has changed, and if that's the case, then they will trigger. The ones here in the middle, not the very middle, but like that, they will just use a timer, and then they don't really care about how things have changed. They just care if it's valid or not. And then we have the one in the middle, which only is triggered by, well, the actual block updates. So it's a pure block update detector, but it's still going to use this condition here, and that has to evaluate it true. But if you leave this blank, so if you you can even do that. So if you do this, and then just use the middle pin there, it's going to be a pure block update detector. So that's everything for now. I hope you find this very useful. I think it can be quite nice to have. I'm not entirely sure what you would build with it at the very moment, but I'm sure you're better than me at thinking of ideas for that. So that's pretty much it. Good luck.